Well, hello everyone. This is the third video in building a bench power supply out of a television power supply board. I know I said I probably wasn't going to finish this up on video, but I figured I started it, I should finish it. First things first, we are connected to mains voltage. You have a lot of exposed electrical components here. This is very dangerous. If you don't know what you're doing, you probably don't need to be messing with this, and I'm not taking responsibility for anything that anybody else does. So there's your warning. Alright, main reason why I'm building the other bench power supply, because this is my main bench power supply I use. This is one I built a long time ago. It's a linear power supply that I have a step-down transformer that got a 60 VA transformer in it. So I got 60 watts to play with. And like I said, it's all linear, and right here I have 7800 regulators in it, all fixed voltage, and then I got a variable right here. Now I've got it designed where I can go from 20 volts with 3 amp output of it, and it works fine and everything except for one thing, because it generates so much heat. It is loud. And it gets annoying. So I'm building the other power supply mainly because I'm going to shrink it up some, where it's not going to stick up so high, and all this junk I stick on top's not going to fall off as much. It's just quiet. So, and this one, it's not going to put out as much wattage, but everything I do, it should get me in the ballpark. So. Alright, this is what I've done to it so far. I went and I put a rubber mat down in the bottom so I wouldn't have any problems with grounding issues or anything short-circuiting. So I secured it to the bottom, and I have this bolted down to the rubber mat, and then I put some feet on the bottom. And then I connected the ground wire and I grounded it to the case, and now I need to check to see if everything is grounded properly. Alright, I get my multimeter and set it to continuity. Alright, I want to check the ground wire here. Let's check it with the plug. Alright, we're grounded there. And let's check it with the case. Okay, we're grounded there, and let's check it with the bolts. Alright, now I want to check it here with the ground wires. Alright, we're good to go. We're safe. So, okay, there's some changes to the design that I'm going to do. I originally was going to use this buck converter here, but I didn't really like that too much, so I went and I got this buck boost converter here, which is ZK-4KX, and it should go from a half a volt to 30 volts, and I think it'll do a constant current of 3 amps, and the output of it is at 35 watts. So let me look on the output here, and we'll figure out which sources we're going to use for a buck boost converter. Alright, so if we have a look right here, we can see our output, which is 3.5 volts at 1.9 amps, and 12 volts at 2.8 amps, and 20 volts at 1.1 amp. Okay, after looking at the data sheet on this buck boost converter, the input of it is 5 to 30 volts, so we know we cannot use the 3.5 volt side, so that's out. So that leaves these two here to figure out. And I'm going to pull out my digital abacus here, and we're going to go 12 volts times 2.8, and that's going to give us 33.6 watts. And then 20 volts times 1.1, and that's 22 watts. So we're going to use the 12 volt side, and because we can have an output of 35 watts on this. And I think on the data sheet it had it's 88% efficiency, so 36 times 0.88. Let's see what we have. And that's going to give us 29.568. So roughly 30 watts to play with, which is going to be plenty. All right, another thing I'm going to do is right here I have one of those mini 360s, and I'm going to connect it to the 20 volt side and step it down and connect this 9 volt jack, battery connector to it, because I use a lot of 9 volt batteries, and I'm just going to have a constant 9 volt battery source coming out of it also. Alright, well I got all my wires laid out and marked, got my switch in, and then I got to noticing I have a 15 amp fuse in here. I need to change that one out. I don't have one smaller, but that's a little too large. But then I got my face plate all laid out. Problem I ran into is the smallest rotary tool I have is a Roto Zip, so you can be over tooled for the situation. It kind of got a little rough on all of it, so. But I've either built a new faceplate or I'll figure out some way to make it look better, but she'll live. Now I'm going to wire everything up. Going to wire the Mini 360 up. I'm going to put it for about 9, I think a brand new 9 volt battery is about 9.48 volts or 9.5 volts, somewhere around there. And I'll wire it up and load test it, see how far it brings it down. But let me get all this soldered up and wired up, and hopefully she'll be put together and I can show you how she works. Alright, well I got her finished. Everything works fine on it. Couple of things that I probably need to go and change. Even though I use the LED calculator, for some reason that's a real dim LED. And another thing that I realized that I need to change in it was my 9 volt battery connector here. I need to put a switch on it that kills it when it's not in use. I mean, I set it around and ground it out anywhere, so that's something I need to go and do to it. But other than that, everything works fine on it. I've done load tests on it. It performs well. This little buck boost converter does a real good job. Yeah, but I'm very happy with it. I'm probably going to might build another faceplate. I'm not real sure. Got into the steel there. You got to gouged it up a little bit, but yeah, other than that, I'm very pleased. So I hope y'all enjoyed this video, and if you got power supplies just sitting around the house, you can buy you a little buck boost converter and build your own bench power supply. All right, y'all have a good day. And don't forget to give me the thumbs up and subscribe.